Good afternoon, 7th graders. I would like to do a video lesson in your math lesson 107, for your math lesson 107. So this lesson talks about number families, and there are certain groups of numbers here that we want to talk about a little bit and discuss and kind of help so we can identify them. And so let's go to the first one here, the counting numbers. By the way, I'm going to be kind of referring to the diagram that was on page 490. I believe that I sent a copy of this diagram home with you. If you don't have one, I can email you one, or you can just draw it or make a copy or whatever. But that is kind of a handy diagram to have. Okay. So the counting numbers. Counting numbers are simply the numbers, obviously, that we count with. And so we start with 1, 2, 3, 4, and on and on and on. Okay? There's nothing negative here. It does not include 0. It's just the counting numbers, 1, 2, 3, 4, 5, 6, 7, and so on. Then the whole numbers would be the counting numbers plus 0. And so it's exactly the same thing, except that 0 is added to it for the whole numbers. And then let's look at the top of 489. If we use a dot to mark each of the whole numbers on the number line, the graph looks like this. And so if we would be asked to draw a graph of the whole numbers, okay? So how would we do that? Well, the whole numbers do not include anything negative. It starts with 0, and so it would be 1, 2, 3, 4, 5, and then just put dots above those numbers that apply. Don't fill in the gaps between the lines, because there's no fractions included in that definition. Whole numbers are not fractions. Now, if we want to graph all the whole numbers, then we would need to put an arrow out here at the end to indicate that this goes on forever in that direction. So we would include 6, 7, 8, 9, 10, 11, and so on, forever. And so this would be the graph of the whole numbers. Integers then are the whole numbers and then the negative numbers, the corresponding negative numbers. And so the integer would be all of these, but then it would also be like -1, -2, -3, -4, and so on. And so a graph of the integers would look like this. And so I would put down 0 here, 1, 2, 3, 4. Okay, and I'm going to put down dots above each one. But don't forget your arrows here, because if I'm graphing all the integers, right, then this would go on forever like this, and it would include a sequence of these dots forever. And then on this side as well, it would include the sequence of these dots forever to the left. And so that's the graph of the integers. Then the rational numbers would include the integers, all the integers plus the fractions. And they put a definition, they give a definition of those fractions. It says includes all numbers that can be written as a fraction of 2 integers. Thus all fractions name a rational number. And so if you look at the next page of 490, then it talks here about the fraction 4 1/5. It could be written as 21/5, or decimals. Decimals can be used as well. And so this whole thing is kind of captured in this diagram that is in the middle of the page. So in the middle, the very middle box would be the most restrictive definition, be the counting numbers, 1, 2, 3, 4, 5, 6, 7, and so on. The whole numbers would be all of those plus 0. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. The integers would be all of those plus the negative numbers. And so the arrow, that's what the arrows go in both directions. And then the rational numbers would be all of the integers plus fractions. So let's look at example 1. Graph the integers that are less than 4. Less than 4. I'm just going to use this for time's sake, I'm just gonna use this line right here. And so, if it's less than 4 would be, 3, 2, 1, 0, -1, -2, -3, and so on, right? But then it would include go in this direction forever. And so that's why that they drew the number line the way they did. And so you start off with 3 because that's the first integer that is less than 4, 2, 1, 0, and so on, with an arrow at this end to indicate that it goes this way, but it would not go that way. Example 2, answer true or false. All whole numbers are integers. Is that true? Well, and that is true because the whole number box fits inside the integers box. And so that would be true that all of the whole numbers are also integers. Let's look at B. B would be all rational numbers are integers. All rational numbers are integers. That is false. Why is that false? Because rational numbers include fractions, and fractions would not be considered integers. And so that is false. And so do your practice problems on this lesson, and I will probably scan the answers because it includes some number lines here. I'll probably scan the answers and get those out to you. See if you can work your way through those, and good luck.